Hello everybody, welcome to another lesson by me, Miss Pythagoras. In this lesson, I will explain the factor theorem. This is lesson 2 of 4. Have you subscribed yet? You can also visit my website. The link is in the comments below. There you will find all the chapters in the syllabus. Let's start with the maths. The factor theorem states, if f of x is a polynomial such that f of b minus a is equal to 0, then ax minus b is a factor of f of x. So what this means is when you do the remainder theorem and your remainder is exactly 0, then we can say that ax minus b is a factor of the polynomial. So where does this ax minus b comes from? Remember, ax minus b is 0, ax is equal to b, and x is b over a. That was the number that you substituted into f. Conversely, we can also say that if ax minus b is a factor of f of x, then the remainder will be 0 when you do f of b over a. In other words, you cannot split the remainder and factor theorem. They go hand in hand. So you do the remainder theorem, and when the remainder is equal to 0, then that number is a factor of the polynomial. Example 1. Determine the remainder when f of x is equal to x cubed minus 3x plus 2 is divided by x minus 1. So again, this is still the remainder theorem where you will say there's your polynomial, and now you're going to substitute positive 1 into x's place, and then you understand why it's positive 1, because they give you x minus 1 and you say x minus 1 is 0, x is equal to 1, positive 1. So you substitute positive 1 in x's place and you end with 1 cubed is 1 minus 3 plus 2, and then the answer is 0. So this means the remainder is 0. And now we can say that x minus 1 is a factor of f of x since the remainder is 0. So if the remainder was 7, then x minus 1 wouldn't be a factor. Example 2. Determine the value of m if x plus 2 is a factor of x to the 3 plus mx plus 3 minus m. Now, what we're going to do is we will take x plus 2, equate it to 0, and x is equal to negative 2. Then it's this x is equal to negative 2 that we're going to substitute into the expression in x's place. And then you will see I equated the expression to 0. Why did I do that? Because it was given that x plus 2 is a factor. So that means the remainder is 0. So you can equate it to 0. Then we will work out the value of m. Everywhere where we see an x, we will substitute negative 2. Therefore, it will become negative 2 cubed plus m times negative 2 plus 3 minus m. Then negative 2 cubed is negative 8. M times negative 2 is negative 2m. In the next step, I multiplied in this plus, and now I'm going to add my like terms. Now I can say minus 8 plus 3 is negative 5. Negative 2m, negative m is minus 3m. And then the 5 will walk across and I can divide away the 3. the negative 3. Therefore, m's value is equal to minus 5 over 3. Example 3. Show, without using long division, that x minus 4 is a factor of g of x is equal to x to the 3 minus 12x minus 16. So the aim here is we will use the remainder theorem. And then when the remainder is equal to 0, then x minus 4 is a factor. So you know that we will do some substitution. What are we going to substitute? We will take x minus 4, equate it to 0, and solve x. So the number that we're going to substitute is plus 4. Into the formula, everywhere where you see an x, you will substitute 4. And then it becomes 4 cubed minus 12 times 4 minus 16. 4 cubed is 64 minus 12 times 4 is 48 minus 16. And when you work that out, you see that the answer is 0. So what you did here was you used the remainder theorem. You got the remainder was equal to 0. Therefore, you can say that x minus 4 is a factor of g of x. Now you know everything you should know on the factor theorem. In the next lesson, I will explain how to do long division in order to factorize a cubic polynomial. Click on the video in the right-hand corner to take you straight to that lesson.